hello, Mr. Kalyan, and welcome to TC Conversations. So I thought with Earth Day and everything happening, and a lot of companies talking about sustainability and moving towards uh, going green, I thought we could stress
Right,
more on those aspects of it. And since you're also primarily working in that area, so to
correct.
begin with, I just wanted to understand, Jindal Stainless is betting big on green hydrogen. What does the transition actually look like on the ground inside a steel plant?
Thank you so much for having me here. I'm glad to be a part of this Deccan Chronicles. Yes, Reshma, nice to meet you. Your first question seems very pointed. That's what's betting big on green hydrogen. Is that what you wanted to know? And what are we doing on the ground?
Yeah.
So hydrogen, if you speak about the hydrogen as a molecule or hydrogen as a industrial use, that has always been part of JSL since it's started its production in stainless steel manufacturing because the downstream processes require hydrogen. Of course, we had been using complex hydrogen like the ammonia, cracked ammonia, we had been utilizing. When we learned about the pure hydrogen being available from electrolyzer, and of course, the electrolyzer has been always there in several steel plants, not with Jindal Stainless, but many other plants, they had been using electrolyzers to produce hydrogen, not green hydrogen. Conventionally, hydrogen was always in use in different forms and in the industry. So when JSL started looking at the possibility of using pure hydrogen, then came the concept of using electrolyzer, which could be powered with renewable energy. And
Mm.
that makes the hydrogen green. So as I say, JSL for it's not a new concept. It's neither a future concept. So we were already prepared to use hydrogen. So we looked at the potential of how hydrogen that we produce through different means and the green hydrogen that we plan to generate or procure, that will come at a commercial parity. And
Mm.
the utilization was always there. So we started introducing hydrogen. And the first one we did was a pilot project in Hisar. And we started, I think we were the first in steel industry to have a green hydrogen, and that to an off-grid green hydrogen powered by entirely green power. And that was installed at our Hisar facility. That was a 90 nm cube per hour, and that was used to replace the conventionally produced cracked ammonia. That gave us the confidence that we could scale it up further in our other units. And then quickly understanding its benefits, we quickly went for another commercial scale uh, expansion at Hisar itself. Back
Mm.
to back, we contracted for another 1500 nm cube per hour. Sorry, we contracted for 600 nm cube per hour, which can be scaled to 1500 nm cube per hour at our Jajpur facility. So this has been already contracted and through a capex model, and that too also, at in the same utilization as that of SR. So primarily, in our case, being a secondary steel producers, we were not into primary production of steel like DRI or any other blast furnace. So for us, the hydrogen usage was more of an energy carrier than that of a fuel. It was
Mm.
not a fuel as a utilization anyhow. So we didn't have to look much into that fuel substitution or the engineering or any other scale or any other issues. We straight away replaced the cracked ammonia with hydrogen. That gave us the confidence. Now, having done this, we will be now looking forward to pushing the hydrogen in other usage like blending in the fuel or even as we go forward, maybe one of our group companies, the Jindal Ferrous, that has come up with a blast furnace, we could look at using hydrogen as a reductant, replacing PCI. So these are our, future plans. But as of now, we have scaled in hydrogen as much as required. We have gone. So this transition was more than about installing the equipment. So if you are asking me about the ground, how does the transition looks like in the ground? It was not just getting new hydrogen and then replacing it. Earlier, the hydrogen was blended. It was like a cracked ammonia, and now it is a pure hydrogen. So that required a lot of engineering, safety protocols, upgrading the controls, and training people how to use hydrogen because it's known to be, highly explosive mixture, not just flammable, it is explosive. So it was being used. So we had to train our people, get experts in this field, and that's when we invested and we started using it. So now, when JSL actually had the pilot phase,
Mm.
first came at the start, till that point of time, even government had not announced the NGHM, National Green Hydrogen Mission. That
Mm.
wasn't announced till then. So it came after that. Right. So announcement was after that. So we were bold enough to carry on with our green hydrogen project, learning it's possible, greening because we already had committed to net zero prior to that. So we saw this as an opportunity to take it forward as a one of our decarbonization project. Then came the National Green Hydrogen Mission, and government announced 19,700 crores outlay for creating the hydrogen infrastructure, hydrogen hubs, and so many things. So we had been, you can say, JSL had pioneered already in this field. So, and we invested early because we believe early movers will build the experience, partnership, and that operational capability needed in the future. So that's it. So hope
Okay.
it
Yeah,
resonates.
that answers my question. So we're talking about net zero. I mean, talking about your net zero target. What are the
Yeah,
toughest trade-offs between scale, cost, and sustainability that you have to navigate?
yeah, very, very, very pointed question. As I see that the world, everybody has committed to net zero by 2050, and even before India started thinking of it and was signatory to the Paris Climate Agreement. Then came the Indian uh, vision for net zero by 2047. So we actually uh, we actually see how the net zero going forward, net zero by 2050 could drive the company towards a ambitious goal of being a carbon neutral or a sustainable producer of a stainless steel. And this declaration of net zero by 2050, this actually resonated with our goals because JSL, being the largest manufacturer in India of stainless steel, the sustainable leadership as the product stewardship and all other attributes given to a corporate who wants to be at a leadership space, leadership position to drive net zero as an ambitious goal, which many corporates worldwide had done. So when we had declared our net zero by 2050, at that similar point of time, I think Indian government also had announced its net zero by 2070. Okay, and we saw it as an opportunity to push our decarbonization agenda. But you see, the biggest challenge is balancing ambition with economics. We wanted to move fast, but this, you see, large scale decarbonization requires major capital investment. And uh, just apart from the decarbonization, means carbon avoidance, when you go for carbon removal, that comes at a very high premium. Decarbonization or the carbon avoidance means you can put up any technology where you do not generate carbon dioxide.
Yeah.
But to replace or remove carbon dioxide produced in your conventional facility where you had already invested, you had already committed your capital and you are already locked in for the next 15, 20 years, 25 years till its lifetime. That is where the challenge is because that process is conventional and it will keep producing carbon dioxide. Let's say the power plant, let's say the furnaces which we have, not the electric arc furnaces, but the reheating furnaces and other where actual fuel combustion takes place. Those had already been planned many, many years ago, even before JSL and came up with this commitment of net zero. We had committed. So the economics do play out in favor of carbon avoidance, where we immediately went forward to, signing of several PPAs, power purchase agreement for wind solar hybrid, that is renewable energy, round the clock renewable energy. There also we were kind of first mover. We had signed our 100 megawatt PPA, RERTC PPA, and interstate PPA. And exactly that's point of the time when government had announced a subsidy for waiver of ISTS charges. So we had already been working on this idea that to have a renewable energy to replace our grid import. So it came along that. I mean, it seems like whenever JSL made a move, at the same time they were facilitating subsidies and government announcements, which actually facilitated this decarbonization efforts in the industry. So those facilitation came just along with that. So we had our first PPA signed in a year somewhere around the end of 2022, and that was our first 100 megawatt. And back to back, we had signed another 200 megawatt for our entities. So in all, in short, you can say we had 1 gigawatt of renewable energy, wind, solar, round the clock energy signed up for BPA. Now these actually gave return because these the renewable energy, their prices, the offtake prices are locked for a period of 25 years. So
Mm.
you see a price stabilization, which you cannot expect that from the grid. You cannot expect from the coal-based generation because coal may go costlier. Who knows? And right now, domestic coal is the cheapest in India compared to the uh, global prices of coal. You see the Brent index, it's quite high. I mean, so India, the domestic coal is actually it's actually subsidized. This government has actually subsidized the domestic coal production and the prices at which the auctions are made. It is much cheaper than that of global prices. So we do not know where the prices might settle in the future. And the grid prices, I mean, the grid prices are they are all of the distribution companies, the production companies, government power sector. So this cannot be our energy security for the future. So when we had the RE, renewable energy, so that gave us a stable energy prices for 25 years. So blended cost of energy will also fall. So these kind of the scale and the cost which we saw for the future, that made sense for signing up for PPAs. But this again, as I told you, this is a carbon avoidance. But when you talk about the carbon removal, that how do I decarbonize my existing process? That's where the carbon removal comes at a cost, like green hydrogen, replacing my coal with the green hydrogen, replacing coal with the biomass. That comes at a very high premium. Then you can say installing the carbon capture and storage or carbon capture and utilization. Those come at a huge capital cost. So those are the final, those levers available for industry. After you know, remove all, sorry, after you done away with all kind of decarbonization efforts like energy efficiency or energy reduction, energy conservation, and replacement, energy substitution, like changing a fuel to a green fuel, replacement of conventional electricity with the RE energy. Then comes the residual uh, carbon that is to be removed through higher efforts like carbon capture. So this actually is a trade-off. The biggest challenge is the ambition, balancing the ambition with economics. So the second challenge is scaling. Right now, these technologies mostly like the carbon capture, they are in a pilot stage everywhere. A complete in steel industry. I'm talking about the steel industry and the scale of such technology to bring up to the scale that it will remove the entire carbon. It's still being worked on. I mean, it's not yet been commercially produced to remove the entire carbon inventory of any plant. So we have to see how these matures in future, how these take off, how the entire supply chain, the financing, skilled manpower, safety, and long-term policy supports, they work in favor of those. So we do not see some sustainability and competitiveness or our product costing as the opposing forces. In the long run, you can say the inaction. If you do not act now, inaction could be a bigger risk because of global carbon regulations, energy link, ESG linked procurement, then border taxes, and so many like CCTS, your carbon tax, that will take precedence in future. So if we do not act now or do not act in the near future, we may be seeing a bigger risk, commercial risk in future. So our direction is clear, and we have already committed to net zero by 2050. And before that, we had committed to 50% reduction by 2035. And we
Mm.
had committed a outlay of around 700 crores toward the decarbonization initiative over the next few years. The approach is totally practical. It is focused first on initiatives that reduce emission and improve efficiency now, while building a clear pathway for larger future shifts like green hydrogen or carbon capture. So that's it.
Okay. So cutting emissions by over 1.4 lakh tons is significant, right? What were the
Yeah.
biggest operational shifts that made this possible?
You see, I already discussed these things. So emission reduction at that scale never comes from one initiative. It comes from disciplined execution across multiple areas.
Mm.
The major contributor, even before we started the renewable energy projects, was the waste heat recovery. Those gave us the major boost in our energy reuse, I mean, energy, whichever is wasted, that to be reused and redeployed in the process. Waste heat recovery, we commissioned boiler that recovered waste heat and generate uh, over 1 lakh tons of steam annually, and that would save around more than uh, nearly 30,000 tons of coal and saves an emission of around 45,000 tons of carbon emission every year. So that gives us the tremendous leverage in keeping our energy footprint lower. Then the renewable energy came. So
Mm.
first of all, we started optimizing our energy usage, then capturing the waste heat. First of all, optimizing the energy means we had been practicing energy conservation all these years. So we had been earning positive energy certificates, means of the PAT scheme. If you had heard about the Perform Achieve Trade by the Ministry of Energy, the BEE had announced the PAT scheme for since 2011-12. So those PAT scheme drove the industry towards conserving energy and then creating a market that whoever is overachieving the energy commitments on energy targets, they will get to earn the certificate. So JSL in all the PAT cycles, it has been earning very high energy certificates. So we earned a couple of about 30,000 energy certificates is already in our kitty. That's we had earned over the three PAT cycles. So that came as first thing that we started with energy conservation. Then came the energy recovery from different processes. Everywhere there is energy, we start converting that into usable power or usable steam. That heat comes into use everywhere. So those things first, then the recycling, and then we have renewable energy installed on-prem. Like we have the one of the I think one of the largest single location solar rooftop solar uh, in industry, where in at least in Odisha, 30 megawatt rooftop solar, captive power, captive rooftop installed within our premises, and that too in the industrial premises, that too in a heavy polluting industry. You can imagine. I mean, people install rooftop solar in clean office roof spaces or those things. We had taken the vow to install solar where within the campus, outside the campus, wherever possible, and of course, it was not a mindless game. It was well focused on the return on investment. Return on investment was always there. So we had taken conscious call. We did the project appraisal, we did the financial appraisal, and then we went ahead with and now realizing the benefits. So we have the 30 megawatts rooftop solar and floating solar. We were one of the first movers or the first ones in Odisha to have a floating solar commission. And uh, that actually generates 45 million units of clean energy and replaces or removes carbon emission by around 32,000 tons every year. And we are also advancing the green hydrogen adoption, increasing scrap utilization, both of which are basically reducing our carbon intensity.
Mm.
So I think these are the major levers that you do: energy efficiency, continuous process improvement, energy substitution, energy recovery, and then for any new technology, bring in those kind of technology which are having low carbon footprint. So the larger message is simple. Real decarbonization comes from a portfolio approach. So we did a actually portfolio mapping. We didn't just take up the projects just like that. We did a portfolio. What exactly we want and how does it fit into our operational strategy?
Okay. So stainless steel is considered a sustainable material, right? But where
Right.
does the industry still fall short in truly closing the loop, according to you?
Stainless steel is sustainable material. It is highly recyclable. I mean, infinitely recyclable. It's durable, fully recyclable, and it's you can say 85% of stainless steel is recovered fully at the end of the life.
Mm.
Stainless steel is highly durable. It is highly recyclable. Everything, all the attributes, all the sustainable material attributes come to it. But if you see the upstream emission of stainless steel compared to that of carbon steel, stainless steel requires nickel and chromium. Producing them from the mines to having those kind of metals or the elements like nickel and chromium, Those are highly energy intensive and highly carbon intensive processes. The extraction of nickel, extraction of chromium from the ores, and extraction of nickel from nickel ores from different mines to having those metals used in our processes. The entire life cycle of those primary metals, or you can say the process inputs, we call it precursors in our terms, that it is outside the operational boundary and it comes as a precursor. So we call it as a precursor. Those are highly in a carbon intensity, high in carbon intensity, and those are highly polluting, and they come from a highly polluting industry. If you shift your focus to these China or this Indonesia where these are
Mm.
produced from smelters, nickel pig iron or those things. They are produced from smelters and coal-fired smelters, and many places those are using the conventional energy. So those are very high order of carbon intensity. So when you use that to produce the stainless steel, so those stainless steel in itself is a metal and a sustainable material. But overall, if you see the life cycle emission
Mm.
or the cradle to gate, or even cradle to not the grave, cradle to gate. I'll stop at the cradle to gate because the grave, I am not mentioning grave because it is recycled. It can be again taken back and recycled. So when you offer the product carbon emission from cradle to gate, it is much higher than that of the carbon steel. So first gap is the production emissions. Even in the scrap usage is high, and we have used the scrap up to we have stabilized up to 72%, variable between 80 and 60. The average is 72%. Melting and refining still requires energy. So where does it come from? This energy, because the melting we use electric arc furnace, and electric arc furnace requires electric energy, which can come from either a clean source or some source which is stable, because we cannot be switching on and off or going up and down just like the renewable energy generation. See,
Yeah.
the renewable energy, even if you have the wind and solar, wind of course has a higher capacity utilization than that of solar. The CUF is higher, but still it is available only at 35%. So how we can be expected to just remain rely on reliance on renewable power? We have to back it up with a stable power. The base load has to come from conventional sources. So our
Mm.
electric arc furnaces, they run on the captive power plant, which we had initially we had begun this plant with the captive power plant support itself. Then that has to remain till the grid is able to provide me the replacement power for captive power plant at the similar cost. That is not possible. No grid will provide you the power we want to import that parity of that of the captive power plant.
Mm.
We are generating power at less than half the cost of grid power. Anywhere you take up anywhere, any state in India, the captive power plant will always be the cheaper option. So a person or an industrialist putting up a steel plant, he will always look at the economics. He will not be, first of all, for in the business viability and the, generating wealth for its stakeholders is more important. So that is where the conventional power comes in as a savior for the energy guzzling industry. I mean, electric energy. I mean,
Mm.
then comes the grid support if grid can support. But that's a distant cry, because the grid itself, in itself is many places, grid itself is not having that kind of capacity to provide the power required in a high intensive energy industry and a big sized steel industry like us. For small scale steel industry, it still can provide. For big steel industry, it cannot. So our reliance will remain till alternate sources like nuclear energy are found out, because nuclear energy is similar to thermal but clean form of energy, not renewable but clean. So only the nuclear energy could be an option in the future, or the grid has enough power to replace all the captive power plants, which is absolutely, I don't think in the near future it's possible, because there's a huge uh, capacity of captive power plant in India. Replacing all of them through grid power or nuclear power is next to impossible in the next 50 years. So the second gap is the scrap ability. The first one was energy mix,
Mm.
because we have to keep depending on the conventional sources for our base load or continuous power. The second is the scrap availability and traceability. So high grade stainless steel needs scrap. I mean, that scrap availability is another challenge in itself. Many industries, they're struggling for the scrap availability. And for us, If you raise the scrap utilization, you have to depend on external sources, and we have to depend on imports from other countries. Many countries are tightening their scrap export. Like European Union, there were some reports that European Union is going to tighten its scrap export. So where does it bring us? I mean, if you intend to raise the scrap usage above 70, 80%, going up to 90% as what the many of the European green stainless steel plants are doing. We could also do that, provided the scrap was available at that scale, or the logistic cost and everything put together. The scrap aggregation, the scrap sorting from different channels, these all are totally aligned for all the producers, not just Jindal Stainless. There are many other secondary steel producers who totally depend on scrap availability, either scrap or DRI. So the scrap will remain a challenge till the overall supply chain is optimized or is more efficient. So I would say because of the recycled content and emission footprint, the stainless steel is a bit higher on the scale compared to carbon steel. But
Mm.
given the life cycle emission, that is cradle to grave, it is much way better than carbon steel. So that is where it brings us that it is actually closing the loop. At the end of the stainless steel is a much longer life, more than 110 years as compared to carbon steel. If you
Mm.
make a bridge out of carbon steel, at the end of 50, 70 years, it requires repair, maintenance, and replacement also. But stainless steel bridge or any infrastructure can last even 150 years. So that is where stainless steel counts. I
Yeah.
hope I answered
Yeah.
satisfactory in that way. In case I'm missing any point, we may discuss.
No, no, I mean, it's fine. So, one last question because we're running out of time. If you could quickly
No
tell me
problem.
this.
Absolutely.
So, with India moving towards Viksit Bharat 2047, how do you
Yeah.
see the role of green steel evolving in everyday infrastructure and urban life?
It's all about green steel is all about demand balance. If there is a demand is created, there are plants, there are steel makers who are already poised to make green steel. One of the leading industry, I think you have heard of AMNS, they got green steel certification already. And there
Mm.
are many other small scale industries also got green steel certification. So because the government had announced the green steel taxonomy, which facilitated the industry to undergo an MRB and get a certification by the government authorized agency, NISST.
Mm.
So that way, the Viksit Bharat, as it moves forward, and if government lays out an ambitious plan that all the green means all the public procurement will be done from through the green material, then the change will be seen. So green steel and everyday infrastructure will change only if there is a push from the government. So Viksit Bharat 2047 will be a realizable dream only if the infrastructure is driven by the green public procurement sense. And
Yeah.
that has to, I mean, that yet has to arrive because government has on one hand, it has created the green steel taxonomy. It is creating the demand generation curve. It is seeing where are the potential, but the mandate on using the green steel in the public procurement or any procurement, it has not yet been done. So where do producers earn their money? Because the green steel, producing the green steel, even if by reducing the emission by 50%, it will raise their cost. Adding green hydrogen, adding renewable energy, replacing the conventional energy. And many places, I mean, removing the conventional energy with grid energy because grid energy is actually its carbon intensity is lower than that of the captive power plant.
Mm.
So if you switch to grid energy, you can reduce your carbon footprint, but grid energy is not abundantly available. So green steel, there are steel makers who are prepared to make green steel, manufacture green steel through dedicated processes and other things. But that it has to from moving from a niche offering to a mainstream demand with a with this thing that it is a highly recycled content, lower carbon intensity, and cleaner thing. So moving on a customer demand that it is no longer a niche demand, niche ask or requirement or demand. It has actually a regular demand. So that shift and the consumer preference, the customer preference has to be guided by several things, like their own downstream demand, like a customer,
Mm.
like a industrial customer who is fabricating something out of a green steel product or a green raw material, like anybody who is serving auto industry, who is serving any other infrastructure industry. they are also required to get their customer demand that they require the end product in green steel. Only then it will get translated into the raw material, that is the end product of steel industry as green steel. So there is a big cycle which has yet to establish because the government has already created the environment, but now it has already created the CCTS and everything that's aligning all the steel industry to lower their carbon emission. But at what cost and for whom? If steel industry is lowering its carbon emission and offering green steel, but for whom? If there are no takers. So
Mm.
we have to see how the government changes or how the government shifts this consumer preferences to at least the public infrastructure preference to using the green material. Only then I think this can scale up and it can lead to the supply chain, sustainable material supply chains.
Yeah.
So
Great.
that's it.
Yeah. Thank you. Thank you so much.
Thank you so much for having
Thank
me
you.
here.